Exercise has powerful effects on fitness, performance and health, but how we prescribe exercise, the frequency, how often, intensity, how hard, time, duration of individual exercise sessions, type, what kind, volume, total amount of exercise, and progression, how exercise is advanced, determines whether those benefits actually happen. Among all the training variables, intensity plays a particularly important role. Yet across different fields, exercise intensity has been described using very different terms. In public health, cardiorespiratory exercise intensity is often labelled as very light, moderate, vigorous, and near max to max, very vigorous or high. In exercise science, intensity is instead grouped into domains, such as moderate, heavy, severe or extreme. As a result, the same exercise intensity can be described in multiple ways. This lack of consistency makes communication difficult, and creates confusion for researchers, practitioners and the public. As the philosopher Thomas Reid wrote, back in 1852, there is no greater impediment to the advancement of knowledge than the ambiguity of words. To address this problem, an international group of experts, led by David Bishop from the American College of Sports Medicine and Exercise and Sports Science Australia, published a consensus statement titled Physical Activity and Exercise Intensity Terminology. The goal was to create terminology that is simple enough for the general public, but accurate enough for sports scientists and coaches. This is Talking Sports Science with a summary of Bishop and Colley's consensus statement. Let's dive straight into the 5 intensity categories. The 5 categories Bishop and colleagues propose are very low, moderate, high, and very high. These categories apply to both cardiorespiratory and resistance exercise, creating a single unified language for describing exercise intensity. Rather than using different terms for different exercise types, the same categories are used across the board. In aerobic exercise, intensity isn't just about how fast you're moving or how hard it feels, it's defined by what's happening inside your body. As exercise intensity increases, we see changes in oxygen uptake, breathing and blood lactate. Rather than getting caught up in different terms, Bishop and colleagues keep things simple by referring to 2 key points, the first and second metabolic thresholds. The first metabolic threshold marks the transition from low to moderate intensity exercise. This is where breathing and lactate first begin to rise above resting levels. The second metabolic threshold separates moderate from high intensity exercise. Beyond this point, fatigue builds much more quickly, and the effort becomes hard to sustain. Very high intensity is defined using a clear physiological marker, the highest speed or power reached at the end of a VO2 max test, an intensity that can usually only be maintained for a few minutes. Very low intensity, on the other hand, has no clear physiological marker, but because moving people from being inactive to doing something is so important for health, this category is included even though its boundary is less precise. Many exercise guidelines define intensity using percentages of max values, such as max heart rate or VO2 max. However, research shows these markers do not reliably place people into the same exercise intensity zone. For example, 2 people exercising at 80% of their maximum heart rate may experience very different levels of physiological stress. One person may be above their first metabolic threshold, while another may still be below it. As a result, these familiar numbers can misclassify exercise intensity for both athletes and the general population. Because not everyone has access to an exercise physiology lab to identify where their metabolic thresholds lie, this is where the rating of perceived exertion or RPE can help. The RPE scale aligns well with the 5 intensity categories. On the 0 to 10 scale, very low intensity is below 2, low intensity is between 2 and 3, moderate intensity is around 4 to 5, high intensity is between 6 and 7, and very high intensity falls between 8 and 10. When it comes to resistance training, intensity is traditionally described using a percentage of 1 rep max. However, this approach doesn't apply to body weight or banded exercises. And much like heart rate in aerobic exercise, load alone does not reliably reflect how hard a set feels or how much fatigue it produces. This is because resistance training intensity is determined not only by the load being lifted, but also by how close the set comes to neuromuscular failure. For example, a load of 50% of 1 rep max may represent moderate intensity during the first couple of reps, but the same load becomes very high intensity as the set continues toward failure. Adding to this complexity is the large individual variation in how many reps people can perform at the same relative load. 2 individuals lifting 70% of their 1 rep max may complete anywhere from 6 to more than 20 repetitions. So rather than relying on load alone, Bishop and colleagues recommend using reps in reserve to describe resistance training intensity. Reps in reserve refers to how many additional reps could be completed before reaching neuromuscular failure. This provides a better reflection of the true neuromuscular stress of a set. Using this approach, very low intensity is more than 8 reps in reserve, low is 7 to 8, moderate is 4 to 6, high is 2 to 3, and very high is fewer than 2 reps in reserve. This approach applies to barbells, machines, dumbbells, resistant bands, and bodyweight exercises. Let's now bring everything together and recap the intensity categories we've discussed. The 5 categories can be applied consistently across different types of exercise. For cardiorespiratory exercise, intensity is defined using physiological markers, such as the first and second metabolic thresholds, and the intensity associated with VO2 max. For resistant exercise, intensity is described using reps in reserve, which reflects how close a set comes to neuromuscular failure. And whether performing cardiorespiratory or resistance exercise, the same 5 intensity categories can be aligned with ratings of perceived exertion to help prescribe and monitor effort in practical settings. This standardized 5-category approach allows exercise intensity to be prescribed, monitored, and communicated consistently, whether the goal is health, fitness, or performance. Before we finish, it's worth stepping back and reminding ourselves why all this matters. Large population studies have examined how the daily duration of physical activity relates to reductions in all-cause mortality. One key finding is that moving from being inactive to doing even small amounts of moderate intensity activity produces substantial health benefits. In general, more exercise is better, but the returns are not unlimited. Importantly, no matter how much moderate intensity exercise you do, you will not achieve the same mortality benefit as when some high intensity exercise is included. At the same time, prolonged high intensity exercise carries a greater risk of injury and other adverse events. This shows that different exercise intensities are not interchangeable. This is why defining, prescribing, and communicating exercise intensity accurately matters. And that concludes this presentation. As always, a link to the full paper is in the description. Thanks for watching, folks. See you next time.